Okay, so the first few questions here are going to be the absolute value. Okay, so number one, can you move algebraically everything out of there except for the absolute value? So you're going to have to get rid of the 7 and the 2 in the correct order. Okay, so get rid of everything else. So add 7. Divide by 2. Okay, that's step one. Just get the absolute alone. Now, this is where I'm going to split it. So the idea is, what could have been inside this bracket? I could have had an 8, or I could have had a -8. So I'm going to drop the brackets at this point because I'm going to make the statement the inside could equal 8 or the inside could equal -8. So do you notice that I had the absolute brackets on until I make my split? Okay, so don't lose a communication error there. Okay, so we get 5x equals 9. So x equals 9/5. On this one, 5x, be careful with your adding with negatives involved. -7. And did you get a fraction again? And we can just leave it like a fraction, and that's all good. Okay. Number 2, so algebra first to get it alone, so we're going to have to subtract 10. Okay, what do you know about absolutes? They can't be negative, so we're going to have no solution on this one. Because the absolute of 8 would be 8, the absolute of -8 would be 8. There's no way we could get that to be a -8. Okay, graphing. So graphing absolutes, there was 3 rules. If your graph is positive and we absolute a positive, nothing happens. If we absolute 0, nothing happens. The absolute of 0 is still the absolute of 0. But if we absolute a negative, what happens if we absolute a negative? It changes. So those are the 3 ideas we're looking for. Okay, so I'm going to draw the part that stays. Which part of this graph would not move? So this portion. So I have to draw it. I noticed that some of you, when you were doing your work, were not drawing, overlapping it. You have to overlap it to say, like, this stays here. Okay, this and this section are both negative. So can you visualize it reflecting to the positive? So reflect it, positive, reflect it, positive. Let's see. So there's my final graph. That's what my graph would look like. Okay, did you also notice that on one end I had an arrow, one end I didn't? That's because that's what was the same with this graph. This had an arrow, so I have an arrow. This doesn't, so this doesn't. Okay, so that's a place that I would say would be a communication error. Okay, next, graph the absolute of this. So first of all, without the absolute, I'm just going to graph what this is. Tell me 3 things you know about this equation when we graph it. 3 quick things. What's a 5 on this? Y-intercept. What's the shape of the object? Like, what does it make when you graph it? What shape? We've learned 2 things, lines and quadratic parabolas. So this one is a parabola. What does this negative do to this parabola? Flips. So we have a parabola like that. So we're going to start at 5. And I'm going to be drawing this light because it's not my actual answer. I still will have to absolute it, but I'm going to draw a little sketch of it. So 1, 1, 2, 4, 3, 9. Like I said, I'm gonna just draw this light. Okay, so downward parabola. Okay, where do I keep it because I'm absoluting it? So I'm going to absolute. Positive stays, negative changes, right? Okay, so what part stays? All this would stay because it's positive and 0. And then these would reflect. So that would be my final graph. Okay, so I just want to clarify on your test, you might see this graph you might see that as a question. Graph the absolute of this function. Okay, that means absolute value. Okay, because we talk about reciprocal functions next. So this question might look like this. Graph 1 over f of x. Okay, so do you see the difference? Absolute, reciprocal. Okay, explain the invariant points on a reciprocated graph. Which point, what kind of point would not move if you reciprocated it? If your point had what going on? A y value of 1? Because 1 over 1 doesn't change, right? Or what else could happen with your point? If the y value is negative 1. Because if you reciprocate it, guess what? Same number. Okay, so with that being said, we can jump into the invariant points on this graph. There's actually going to be 3 points that are not going to move. Can you think about what those 3 points are going to be? 3 points that are not going to move. Okay, so anytime you saw a height of 1 or height of -1, those do not move. Okay, we also talked about a special height of 0, because if your y is 0, what's the reciprocal going to do? Do you remember what the reciprocal did? What is the number 1 divided by 0? Undefined. So that's where we do this. What was that really funky word? Remember, it starts with an A? An asymptote? Okay, so where there's a height of 0, so that's here and here. So it's a dotted vertical line. Oh, there's another invariant point. Sorry, I missed this one. Okay, let's do this middle section first, I guess. Okay, I'm going to do this, just this section. This highest coordinate was 1, 3. Where am I going to move that coordinate to? So I'm going to move it to a coordinate 1, 1/3. So instead of a height of 3, it's going to be a height of 1/3. So it was the highest point in this section, so now it's going to be the lowest. So from there I'm going to go up, and then up, 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 up. So if it's the lowest, I'm going to go upwards, and then upwards, upwards, upwards. Okay, here's the thinking and process too. Like this zone right here, I'm getting closer to 0, so now I'm going to shoot away from 0. Okay, let's do this right section. So this was the lowest point. Now it's going to be the highest. So in that section, I'm just going to shoot away from 0, because this was getting closer to 0, so I'm shooting away from 0. Okay, now the last section. This portion is getting closer to 0, so I'm going to shoot away from 0. This portion is shooting away from 0, so I am going to shoot closer and closer to 0. And that created something else though. Because this is going to get closer and closer and closer and closer and closer to 0, because it's an arrow, I now have to make an asymptote as well right here. I didn't here because this stopped. It didn't get closer to 0, it just stopped. But here, because this went away from 0, I get closer to 0. If I'm getting closer to 0, I have an asymptote there now. Okay, next. solving an inequality, nonlinear. Okay, so I'm going to first factor this and figure out where did it equal 0. So it multiplies to 32. You're going to need an 8 and a 4, right? Okay, minus 8 plus 4. Okay, now I'm going to make a number line here. And I'm going to put a -4 and an 8 on it. So I'm going to pick x values, see what's happening with my y values. Okay, so at this x, y is 0. At this x, y is 0. Now let's figure out all the in-between intervals. So I'm going to test some x value. What's a good x value in that zone? I don't know, -6. Okay, I'm going to plug it into these brackets. So -6 minus 8, negative. -6 plus 4, that's negative. 2 negatives, positive. Okay, I'm going to test an x value in this zone. And I'm going to pick 0 because it's in between there. At a snap of a finger, I know it's negative because if x was 0, I would have -32. Okay? Or if you plugged it in, this bracket's negative, this one's positive. Okay, and the last, I'm going to test anything above 8, so I'm going to go with a 10. So 10 minus 8, positive. 10 plus 4 is positive. 2 positives, positive. Okay, so now what's the whole question here? Where are we greater than 0? So greater than 0 means positive. So that's this zone and this zone. So I'm going to write them. So from -infinity to -4. And then you have your options of round or square. So I don't want to include it because I can't include 0. So round bracket. And then this is 8 to infinity. Okay, solving systems of nonlinears. When I look at this, what do you want to do with it? Do you want to substitute, eliminate, or graph? Well, it says we have to graph, but when you just look here, so do you want to do a substitution or an elimination? Which one would look easier on this example? I think I'm going to pick substitution. So y is equal to 2x plus 1. I can move that and replace the y, right? Okay, there's my substitution. Now, when I see stuff like this, I see x's, I see x squareds. That's two variables, so I'm going to zero one side. X squared is the boss. Okay, so I'm going to have an x squared. I'm going to have a minus 2x and a minus 3. Okay, so we have factoring techniques, so I'm going to see if that will factor. 3 times 1, I got to make a negative 2. So I get x equals 3, x equals negative 1. Okay, that's not your answer though. That's not the full answer anyway. When x is 3, how much is y worth? So I'm going to go, it doesn't matter which one you do here. Whatever one looks like it's easier math. I don't know, I'm going to pick this one. Y equals 2 times 3, 6 plus 1. And then plug in a negative 1. Y equals 2 times negative 1 plus 1. So negative 2 plus 1 . Okay, so I'm going to solve this also by graphing because it tells me I need to. Okay, so this would create a parabola. This is creating a line. I don't know, what do you want to do first? The parabola? Okay, so I know this parabola. Negative 2. That's where it's going to start. 1x squared. So that pattern is 1, 1, 2, 4, 3, 9. Okay? 1, 1, 2, 4, 3, 9. So make sure you got all your points nicely dotted so you can see them. Okay, now I'm going to do the line. So plus 1 is the y-intercept. The slope is 2. Which is 2 over 1. So I'm going to go up to right 1, up to right 1. Okay, so the solution is, where did they intersect? So this coordinate is 3, 7, and this coordinate on the intersection is -1, -1. Hey, look at that. It matched our algebra, right? Okay, graphing linear inequalities. Okay, so let's just start by saying when we want to graph our lines, we want them all to kind of have this flow. We need y alone, which will let us see what the m and the b is. Okay, so the first line, that to me doesn't look like y mx plus b. So here's what I'm going to do. I'm going to keep the y. I'm going to move the x, so -2x. And I didn't move the 9 part, so the 9 part doesn't change. Okay, now I'm going to divide by 3. Okay, it's ready to graph. So -3, that's the y-intercept. The slope tells me to go down to right 3. Down to right 3. Okay, now, what kind of line will I draw? I have two options. Is this a dashed or a solid line? So I look at the inequality and it says I could be greater than or I could be equal to. So I could be on the line, so it can be solid. Now, which side will I be on? Which side, the dice or the penny? Which side is the greater than side? The dice is on the greater side. Okay, because it's angling upward. So I'm just going to draw myself some little cheating arrows like that. That's the side I would want to be on. Okay, next. Here's the second line, and again, it doesn't have the form that I want. Okay, so I'm going to keep the y. Move the x. I guess the number doesn't move. Okay. Now I'm going to have to divide by -3. Something crazy just happened though. Remember a rule? If you divide by a negative, do you remember something weird that happens that you're going to have to remember? Your inequality sign is going to flip around. Okay, two negatives here. I can rewrite them as a positive. And this is two negatives, so that would be positive as well. Okay, now it's ready to graph. So plus 1, that's a y-intercept. I'm going to go up 2, right 3. So once I have 2 points, I'm going to draw the line. Is it dashed or solid? And here it says I'm allowed to be equal to it. So I'm solid. Okay, now I have 2 choices for the sides that I want to be on. Greater than, less than, where do I want to be? I want to be less than it. So the dice or the penny would be on the less side. So the penny in this situation. Okay, and the last line, we have x is less than 7. So what is that? It's a special line. Is it a vertical or is it a horizontal line? Those are your 2 options. When you don't have an x and a y, just one of them. So where is x7? Here, here, here. I'm drawing any point where x is 7. So it's creating a vertical line. And this says less than, so I can't be equal, so I'm dashed. And I have to be less than, so think about which side of that line do you want to be on if you're less than that line. So the less is left. So I have to meet all my criteria. I have to be that side, that side, that side. And it looks like I'm right here then. Anything, any coordinate in that zone will work. All right, last question. All right, solving a system of 3 equations. So when we first look at this, we're going to commit to getting rid of one of the letters. So you have to just pick and commit to that right now. Which one do you want to do? X, Y, or Z? Y? Okay. Eliminate Y. Eliminate Y. We're going to be doing it twice. Okay, so I think I'm going to go equation 1 and 2 together. So can you write equation 1 and 2? Okay, we decided Y's. So now I look and I say, will I add or subtract? How do I get rid of those? I'm going to have to add them together. Okay. -2 plus a 3 makes 1x. That's gone. Z plus Z makes 2Z. And 14 plus a -5 makes 9. Okay, and just for my organization, I'm going to call that the 4th equation. we're going to repeat, but we can't use 1 and 2. So what do you want to do? 1 and 3 or 2 and 3? Those are your other options. So I'm going to go with 1 and 3. But I'm going to times that by 2 so that I'm going to set up a 2y on it. I'm going to times it by 2 to match the other 2y. So equation 1, and then I'm going to double I almost made a mistake. I almost forgot that I have to double everything. Okay, we decided y's. We were committed to getting the y's out of there. Adding or subtracting. So I'm going to subtract. If I see something that's the same, I subtract them. The S and S. Same, subtract. Okay, so this actually ends up out of there too. This is gone. 1 subtract -4 actually adds 4. So that's 5z. And again, I subtract a negative value, so now that's adding. So 30. And actually, I can solve right away. Normally, that doesn't happen. This would usually give you your 5th equation, and then you put 4 and 5 together, right? But this was like a bonus because I double canceled. Okay, now we have one value. So you start the plug-in process. The first plug-in is into the 4th or the 5th. Then you go up to the 1, 2, or 3. Okay, so x plus 2 z's, which I know. X plus 12 equals 9. Okay, I know z, I know x, so we got to get the y, which means I'm going to go into any of these. I don't know which one looks easier. Well, I'm just going to go with the first. So there's me plugging in x, plugging in z. So I'm going to keep working at that.